Space is mostly empty. That's what we all learn in school. Just darkness, stars scattered here and there, and huge distances between everything. But what happens when something incredibly massive starts moving through that emptiness at insane speeds? What happens when that massive thing isn't supposed to be moving at all? The Hubble Space Telescope has been capturing images of the universe for decades. Every week, it sends back pictures of distant galaxies, exploding stars, and cosmic events that occurred billions of years ago. Most of these images show us things we already expected. But sometimes, just sometimes, Hubble spots something that doesn't fit any of our explanations. That's exactly what happened in 2023. And when it did, the scientists examining the images couldn't believe what they were looking at. A team of astronomers was studying a small, distant galaxy. Nothing unusual about that. Astronomers study thousands of galaxies every year. But when they examined the data Hubble had sent, they spotted something that shouldn't exist. There was a line of stars. But this wasn't just any line. It stretched across space for nearly 200,000 light years. To put that in perspective, our own Milky Way galaxy, home to 200 billion stars, is roughly 100,000 light years across. This line of stars was almost twice the width of our entire galaxy. And it was completely straight. Perfectly straight, as if drawn with a ruler. The oldest stars in the line were blue and young, newborn stars, and there were millions of them. Their combined mass equaled around 100 million suns, all packed into one thin line. When the lead researcher, Peter Van Dam of Yale University, saw the image, he said something that any astronomer would immediately recognize as historic. He said, "Nothing like this has ever been observed anywhere in the universe." Think about that for a moment. We've studied space for centuries. We've witnessed supernova explosions. We've watched galaxies collide. We've seen stars born and stars die. And still, no one had ever seen anything quite like this. The obvious question followed. What could create a perfectly straight line of newborn stars stretching across 200,000 light years of empty space? Whenever you spot something strange in astronomy, the first step is to make guesses, what scientists call hypotheses. Researchers put forward three main possibilities for what this line might be. The first was straightforward. Maybe it was simply a very thin galaxy, one so flat and edge-on to us that we were only seeing its narrow edge. Maybe what looked like a line was really just the side profile of a galaxy, the way a sheet of paper looks like a line when viewed from its edge instead of face-on. But that explanation didn't hold up. When they examined the light from these stars more closely, they noticed something odd. Every single star was young, and everyone was blue. In an actual galaxy, stars span a wide range of ages. Some billions of years old, some only a few million. Their colors vary, but here every star shared the same age and the same color. That was the first warning sign. There was more. At the very front of the line, the leading edge, something else stood out. The light coming from that region carried a very particular signature: superheated oxygen. Not ordinary oxygen, but oxygen so energized that its electrons had been stripped away entirely. Producing that kind of oxygen demands extreme conditions that don't occur just anywhere. This was clearly something unusual, so the thin galaxy explanation was abandoned. The second idea was that this might be jet-induced star formation. We know that some galaxies emit jets of energy, cosmic streams of radiation and particles traveling near the speed of light. When these jets strike clouds of gas, they can sometimes trigger the gas to collapse and form new stars. There were even known examples of this happening elsewhere in the universe. A galaxy called Minkowski's object displayed this pattern, and so did Centaurus A. So perhaps a powerful jet from a nearby galaxy had produced this line of stars. But there was a problem. If a jet were responsible, it would be widest at its far end. That's simply how jets behave, spreading out as they travel farther from their source. Yet this line did the opposite. It was narrowest at the tip and widest near the galaxy that supposedly produced it. Also, if a jet were the cause, the most intense activity should occur close to the originating galaxy. Instead, the most intense activity here was at the far tip, the greatest distance away. Everything about the jet explanation ran backward. So that theory was also dropped. By this point, the scientists understood they were witnessing something rare, something never seen before, and they began entertaining an idea that sounded almost outlandish. What if this wasn't caused by a jet at all? What if it wasn't the edge of a galaxy? What if this line had been formed by something racing through space at extraordinary speed? What if something enormous was hurtling through the universe, and this trail of stars was simply what it left behind? What if it was a black hole on the run? For a long time, the notion of a runaway black hole existed only as theory, confined to the equations and simulations of physicists. No one had actually observed one. But scientists had solid reasons to believe they should exist. Back in 1983, physicist Michael Fitchett worked out the math behind it. He showed that when two black holes merge, the process isn't smooth. The merger releases energy in the form of gravitational waves, and crucially, those waves aren't emitted evenly in every direction. The release is lopsided, uneven, asymmetric, and when energy escapes unevenly, it produces a kick, much like the recoil of a fired gun pushing back against your shoulder because the bullet leaves unevenly. When two black holes merge, the resulting black hole receives such a kick. This kick can be powerful enough to launch the newly formed black hole entirely out of its home galaxy, sending it flying through empty space at speeds of hundreds, even thousands, of kilometers per second. A cosmic bullet in flight. But there was no proof. It remained just math, just theory. Then came the Hubble image in 2023, a line of newborn stars, and scientists began wondering, could this be the wake left by a fleeing black hole? To find out, they needed sharper data. That came in December 2025, when they turned to a far more powerful instrument, the James Webb Space Telescope. This telescope offers vastly greater detail than Hubble, like upgrading from ordinary glasses to a much stronger prescription. When they pointed James Webb at the line of stars, what they saw confirmed everything. At the very tip, the leading edge, they found what looked like a cosmic shock wave, a bow shock. You know the sensation of driving through rain with raindrops striking the front of your car and spraying outward? Or a boat moving through water, pushing it aside and forming a wave ahead? That's a bow shock, a medium being displaced by something moving through it. The same phenomenon was occurring here, except instead of a car pushing through air or a boat through water, it was something colossal pushing through the gas and dust of space. The gas at the very front of the line was superheated, showing signs of compression. Its velocity shifted suddenly, moving at supersonic speed. Everything pointed to one conclusion. Something enormous was racing through space at tremendous velocity, generating a shock wave as it went. The mass involved was staggering too. The black hole at the center had to weigh at least 10 million times the mass of our sun. That makes it a supermassive black hole, and it was traveling through space at roughly 1,000 kilometers per second. So fast that if it passed near our solar system, we wouldn't even notice until it had already gone. The scientists confirmed their finding and named it Runaway Black Hole 1, or RBH1. For the first time in history, there was physical evidence that a runaway supermassive black hole truly exists. But there was a major problem. We think of black holes as cosmic destroyers. They pull everything toward them. Stars are torn apart. Planets vanish into nothingness. Not even light can escape. A black hole represents the ultimate destructive force in the universe. So how could this one be creating stars? How was it leaving behind a trail of millions of newborn stars? The answer turns out to be genuinely beautiful. As RBH1 races through space at incredible speed, it compresses the gas and dust ahead of it. The shock wave heats everything up. As this heated, compressed gas trails behind the moving black hole, it begins to cool. As it cools, it mixes with the surrounding gas in space. And here's where the magic happens. Once all this gas cools and blends together, it doesn't remain a smooth, uniform cloud. Gravity begins acting on it. The gas gathers into clumps. Those clumps grow denser. The denser they become, the stronger gravity's pull on them grows. Eventually, the clumps become so dense and heavy that nuclear fusion ignites at their cores. A star is born. This process repeats again and again. One clump becomes a star, then another, millions of times over, all within the wake of this fleeing black hole. So here's the strange irony. A black hole meant to destroy everything is actually seeding the universe with new stars. The very violence and chaos of this runaway supermassive black hole creates the conditions needed for life, for planets, for everything else. It's the most destructive force imaginable, producing the most constructive outcome possible. Now scientists knew what it was, but they still didn't know where it had come from. How did a black hole end up racing through space at 1,000 kilometers per second in the first place? The answer lay in the path it had taken. Because it left a trail behind it, astronomers could trace that path backward, much like following footprints back to their origin. They followed the line of stars, followed the direction it pointed, and traced it back to a specific location, a galaxy system that resembled an owl so closely that astronomers nicknamed it the Cosmic Owl. Some called it the Infinity Galaxy. This cosmic owl sat roughly 7.5 to 9 billion light-years away. It was unusual, appearing to have two large eyes and a pointed beak. That's because it wasn't a single galaxy at all. It was actually two galaxies that had collided and merged. But here's the truly strange part. These weren't ordinary galaxies. They were ring galaxies, and ring galaxies are extraordinarily rare, making up only about 0.01% of all galaxies in the universe. Only a few hundred are known to exist. Why so rare? Because forming one requires nearly impossible odds. A ring galaxy forms when one galaxy passes almost directly through the core of another. Picture throwing a dart at a dartboard. You could throw it 1,000,000 times and probably never hit the exact bullseye. Galaxies work the same way. The odds of one passing almost directly through the center of another are close to zero, so a single ring galaxy is already remarkably rare, but the cosmic owl contained two of them, two rare ring galaxies colliding with each other. The odds of that happening were so slim it shouldn't have occurred at all, and yet it did. And when it did, something extraordinary followed. When these two ring galaxies collided, it wasn't a gentle graze. It was a violent, chaotic event lasting millions of years. Picture two freight trains barreling toward each other and colliding head-on. That's closer to what this looked like. At the center of each galaxy sat a supermassive black hole. That's normal, since most large galaxies host one at their core. These two black holes didn't collide instantly. They spiraled around each other, drawing closer and closer under their mutual gravity, until they finally merged into a single, more massive black hole combining the mass and energy of both. When two black holes merge, energy is released, but not evenly. The gravitational waves emerge stronger in one direction than another, lopsided and asymmetric. And when energy is released asymmetrically, it produces a recoil. That recoil was massive, powerful enough to eject the newly merged black hole clean out of its galaxy, launching it into space like a cosmic cannonball at roughly 1,000 kilometers per second. And that's where we find it today. Still traveling, still forging stars in its wake, still journeying through the universe after billions of years. This discovery reshapes how we think about the universe. For a long time, we assumed black holes were fixed in place. Once a supermassive black hole forms at a galaxy's center, it stays there, anchoring that galaxy forever. But now we know that isn't always true. Black holes can be ejected. They can escape. They can wander through the cosmic void. And when they do, they can create. But here's the question. Is RBH1 one of a kind? Is it the only runaway black hole out there? Probably not. Galaxy mergers happen constantly throughout the universe. Whenever two galaxies merge, their central black holes merge too. And whenever black holes merge, there's a chance the recoil will be strong enough to eject the resulting black hole from its galaxy. So there should be more out there, and there probably are. Astronomers have already identified some candidates. One is a galaxy called J-Zig-Shaw 437Plo-22456, located about 228 million light-years away. Something odd stands out about it. It has a supermassive black hole at its center, but that black hole appears to be moving at a different velocity than the rest of the galaxy, as though it doesn't quite belong, as if it has its own distinct speed, like it was ejected and hasn't fully departed yet. Then there's Abel 2261, a galaxy cluster whose central galaxy should host one of the largest supermassive black holes in the entire universe, with a mass estimated between 3 and 100 billion suns. But there's a problem. Scientists can't locate it. The black hole is missing. Some astronomers suspect it may have been ejected by a merger, just like RBH1, and could be drifting somewhere out in space, leaving a trail we simply haven't found yet. And here's what's especially exciting. We're about to get much better at spotting these runaway black holes. The Hubble Space Telescope is set to launch soon. The Nancy Grace Roman Space Telescope will soon survey the sky with clarity comparable to Hubble's, and scientists are beginning to apply machine learning and artificial intelligence to sift through telescope data, software capable of spotting the thin, faint lines that human eyes might overlook. If we can locate more runaway black holes, we can answer major questions. How many exist? How often does this happen? What fraction of supermassive black holes get ejected from their galaxies? It could transform our entire understanding of how the universe operates. For now, we have one confirmed runaway black hole, one cosmic refugee, one trail of millions of newborn stars left behind by a black hole racing through the void. RBH1 is still out there, still moving at 1,000 kilometers per second, still forging stars, still leaving its mark on the universe. When we look at the universe, we often picture it as a realm of destruction, explosions, collisions, death, and those things are real. The universe is violent, but RBH1 reminds us of something else. Even within that violence, even amid that chaos, creation happens. Beauty exists. Life is born. A black hole that should destroy everything is instead planting seeds. Seeds for future stars, future planets, future life. Sometimes the most destructive forces in the universe turn out to be the most creative. Sometimes what we assume can only destroy is actually responsible for some of the most beautiful and astonishing things we witness. And that's what makes this discovery so remarkable. That's why RBH1 matters. Not simply because it's a runaway black hole, but because it reveals that the universe is stranger, more intricate, and more wondrous than we ever imagined. There are still mysteries out there. There are still discoveries waiting to be made. There are still things capable of completely transforming how we see reality. And all it takes is to keep looking, keep searching, keep wondering, keep asking questions. Hubble revealed one thing flying through space that shouldn't exist. What else is out there? What other cosmic wonders remain undiscovered? What other seemingly impossible things are hidden in the darkness of space? That's the real discovery here. Not merely that a runaway black hole exists, but that our universe is far more mysterious than we ever realized. And that means there's so much more left to learn. When scientists announced RBH1's discovery in late 2025, the astronomy community exploded with excitement. Within days, dozens of research teams around the world began examining the data. Universities launched new studies. Conferences were organized. Everyone wanted a deeper understanding of this cosmic refugee. But the excitement wasn't just about confirming that runaway black holes exist. The real excitement centered on what this meant for everything else we thought we understood about the universe. For decades, astronomers had built their understanding of galaxies on one simple assumption. Every large galaxy hosts a supermassive black hole at its center, and that black hole remains there permanently. It anchors the galaxy. It shapes how the galaxy grows and evolves. The black hole and the galaxy are bound together forever, but RBH1 upended that assumption. If black holes can be ejected from galaxies, then our entire models require reconsideration. Our calculations about how galaxies evolve might need to be redone. Consider it. A supermassive black hole at a galaxy's center influences everything around it. It shapes how stars move. It affects how gas flows. It influences the galaxy's entire structure. So what happens when that black hole suddenly departs? What becomes of the galaxy left behind? No one had ever seriously considered this before, simply because no one thought it was possible. The team studying RBH1 began searching for answers. They revisited the galaxy RBH1 had come from, the cosmic owl. What did it look like now? Had the loss of its central black hole changed it? What they discovered was telling. The cosmic owl appeared disrupted and disturbed, as though something violent had recently happened to it, which made sense, since something violent had indeed occurred. A galactic merger followed by a black hole ejected at tremendous speed. But this raised a bigger question for the scientists. If this had happened to the cosmic owl, how many other galaxies out there had experienced the same fate? How many galaxies were missing their central black holes? This opened up an entirely new field of study. Astronomers began combing through old telescope data, searching for galaxies that seemed off, galaxies that didn't fit established models, galaxies with something missing, and they found them. Several candidates emerged, galaxies that appeared to be missing their central black holes. One was a distant galaxy within Hubble 2261, a galaxy cluster where hundreds of galaxies are packed tightly together. At the center of this cluster sits a giant galaxy that should host a massive supermassive black hole, somewhere between 3 and 100 billion times the mass of our Sun. But when astronomers looked closely, they couldn't find it. It was gone. The leading explanation: it was likely ejected, just like RBH1, possibly millions of years ago, and may now be wandering somewhere out in space. Another candidate was a galaxy called J024P56. Its name shortened in casual reference. Something strange stood out about it too. Its central black hole appeared to be moving at a different speed than the rest of the galaxy, as if it didn't quite belong, as if it had its own velocity mismatched with its surroundings. Astronomers describe this as being offset from the galaxy. What could cause that? If a black hole had recently been ejected but hadn't fully escaped yet, it would display exactly this kind of behavior, moving at its own speed, distinct from the galaxy, appearing offset. So within just a couple of years of confirming RBH1, astronomers had already identified multiple candidates for other runaway black holes. The implications began to sink in. If runaway black holes are common, the universe is far more dynamic than we assumed. Galaxies aren't static systems that remain unchanged for billions of years. They're places where dramatic events unfold, where supermassive black holes get ejected, where everything gets reshuffled. This meant our theories of galaxy evolution needed revision. Our computer models needed revision. Our textbooks needed revision. But there was something even more intriguing. If black holes can leave their galaxies, where do they go? How long do they persist out in space? Do they eventually fall into other galaxies? Do they collide with one another? Some scientists began running computer simulations, modeling what would happen if runaway black holes traveled through galaxy clusters. The results were remarkable. Sometimes a runaway black hole from one galaxy would eventually drift into another, merging with that galaxy's central black hole and triggering yet another merger, another kick, another possible ejection. This created a kind of cosmic cycle. A runaway black hole departs one galaxy, drifts through space, falls into another galaxy, merges with its central black hole, gets ejected again, and the cycle continues across billions of years. These wandering black holes drift through the universe like cosmic nomads, forging trails of stars, shaping galaxy evolution, transforming the universe around them. One thing that fascinated scientists was the trail of stars RBH1 left behind. This wasn't interesting merely for its beauty. It raised an important question. How many such trails exist out there? If multiple runaway black holes exist, there should be multiple trails, multiple lines of newborn stars stretching across space. So scientists began searching. They combed through Hubble data. They combed through James Webb data. They examined data from other telescopes. They found hints, possible trails, possible signatures of other runaway black holes. Some of these signals were extremely faint, barely visible, but present nonetheless, suggesting the universe might be full of these cosmic trails, that the sky itself might be streaked with lines of newborn stars created by wandering black holes. This excited scientists for another reason too. These trails could serve as cosmic roadmaps. By studying a trail, researchers could determine where a black hole originated, where it was heading, and how fast it was traveling. The trail tells the story. RBH-1's discovery also prompted scientists to think about upcoming technology that could deepen our understanding of runaway black holes. The Hubble Space Telescope was scheduled to launch soon, designed to scan vast areas of the sky and capture images of distant galaxies and events. With its wide field of view and strong resolution, it could potentially detect more runaway black holes, more trails. The Nancy Grace Roman Space Telescope was also on the way, built to capture Hubble-quality images across enormous swaths of sky, capable of spotting faint objects that Hubble might miss, objects like distant trails left by wandering black holes. But there was something even more exciting. Scientists were beginning to apply artificial intelligence and machine learning to the task, training computer programs to recognize the relevant patterns. These programs could sift through billions of data points from telescope observations and pinpoint which ones carried the signature of a runaway black hole, the bow shock, the trail of stars, the velocity signature. With AI assistance, researchers might uncover dozens or even hundreds of runaway black holes, enough to understand how common they truly are, enough to understand their behavior, enough to genuinely map out this new phenomenon. But another question lingered, one that troubled many scientists. If RBH-1 creates stars in its wake, what happens to the stars that already existed in its path? When a black hole moves through space at 1,000 kilometers per second, it doesn't gently nudge things aside. It destroys them. Any stars caught in its path would be torn apart. Planets would be vaporized. So while RBH-1 creates new stars in its trail, it simultaneously destroys old stars directly in its path. It is at once creative and destructive, building and demolishing in the same motion. This raised a philosophical question. What is the net effect? Is RBH-1 good for the universe or bad for it? Does it create more than it destroys? Some scientists argued it doesn't really matter. The universe is simply too vast, and one runaway black hole, even one producing millions of stars, is just a small blip within the larger cosmos. Others countered that it does matter. Every star represents a potential home for planets and life, and destroying some while creating others fundamentally changes the universe. The debate continued and likely will continue for a long time. RBH-1's discovery also led scientists to wonder about the broader history of the universe. Across the past 13.8 billion years of cosmic history, how many runaway black holes have there been? How many black holes have been ejected from their galaxies altogether? Some estimates suggest this phenomenon may be far more common than previously thought. Galaxy mergers happen regularly. Black hole mergers should happen regularly. Ejections should happen regularly too. Perhaps there are thousands of these events, maybe tens of thousands, maybe even more. If that's the case, the universe is filled with cosmic refugees, wandering black holes, forging trails of stars, driving dynamic, chaotic events that continually reshape the cosmos. We simply hadn't noticed because they're so distant, so faint, so difficult to detect. But now that we know to look for them, we might start finding them everywhere.